The question here it is that the dynamic impedance of an parallel resonant circuit is given by. So the dynamic resonant. So resistance means here. So it is a parallel circuit means we know that there are three components: resistor, inductor, and capacitor. Okay. So this is a ideal circuit of RLC circuit here, RLC, and the dynamic impedance is nothing but the derivation here. So ZD dynamic impedance is nothing but L by C into R. It's an important formula here. Suppose if the same question is asked for series RLC circuit, okay, then the dynamic impedance, so same value here, R here, L here, C here. So ZD will equal to R here. That means what's the meaning of this one here? It is for what value of the impedance at resonance. At resonance means the inductive reactance capacitor will get cancelled here. Okay, that's the impedance here. So in case of a series circuit, Z is equal to R. In case of parallel resonance circuit, Z is equal to L by R. So this same formula is asked in different manners by giving the values of L and C in other competitive exams. So okay, so be aware of this formula here. It's a very important formula here. Okay, and this will be Z is equal to R here. So it's in series circuit here. Okay. So from this the question will be Z is equal to L by RC. So from that I will say one more formula here. So tau is equal to L by RC, basic formula. It's having units of what? It's a units of seconds. Okay. So tau is nothing but RC also we can write. Okay. Tau is nothing but L by R, or tau equal to RC here. See, if ZD is nothing but inductance L, what we can write here, it is a L is nothing but tau is in seconds, R is in ohms. So units are second ohms here. Okay. Now apply the formula here. So ZD is nothing but L is nothing but second ohms divided by RC means it's a time, seconds. So seconds gets cancelled and answer will be ohms here. Like that you also can cross check the answer. Okay. Now next question here, that is the rated line to the rated voltage of a three-phase power system is given by. So the power system rated voltage of a power system is given by the basic formula. It is, suppose if we take the three phases, then P three phase is equal to 3 into V phase into I phase into cos phi. It's a general formula here. Okay, but the actual formula what we will use is three phase applies 3 we do 3 into V line to line into I line into cos phi here. Okay, so P three phase formula. So this is a formula in terms of single phase, and this will be in terms of three phase. But what is the question asked? The rated voltage of three phase power system. So three phase means we will use this formula here. Why? Because this formula is valid for a star connected network as well as delta connected network. Star or delta, so both are same only. So this is a standard formula here. In this one, the value of VL is nothing but line to line voltage. Okay, line to line voltage. Okay, IL into cos by L. So answer will be RMS line to line voltage. Okay, next question here. Sorry. To improve the power factor in three-phase circuits, the capacitor banks connected in delta to make. So the question here it is, the hint given, what is, we are using the delta connected capacitor bank to improve the power factor. Okay, so delta connected capacitor bank means it is like this. Here we have one capacitor, another capacitor, another capacitor. So let's say C1, C2, C3 like that. Okay, so these are three phase manner delta connection. Okay, now why it is, sir? So generally we know that the resistance or impedance Z in delta will be equal to 3 times that of ZS. So this is a basic formula here. Okay. Similarly, if you take a capacitance in delta will be equal to capacitance star divided by 3 times. For example, see here, when the capacitance value is connected in star is equal to, okay, so to make it understanding, I'm making this CS will be, let's assume, so 3 farads as an assumption. Okay, when the capacitance in star it will be 3 farads. What about the capacitance in delta here? It is nothing but 3 by 3 farads. That means equal to 1 farad here. That means you can observe here The capacitance value when it is in star connection is 3 farads. The same capacitance value in case of delta it is 1 farad. That means what is the advantage here? You can reduce the capacitor size. So you know that C is equal to basic formula epsilon naught epsilon or A by D here. Okay, if you are decreasing the capacitance value, what about the area of the plates? Decreases, so that size will be decrease here. So answer will be capacitance will be very small. The capacitance calculation will not be easy. That's different. Okay, the connection is elegant. No, that's wrong. The power factor connection is more effective. It's wrong. Okay, the power factor will be more improved here, and the capacitance value will be very small in value. So capacitance is very small. Okay, remaining options are wrong options, right? Next one here. So see the question here. This is the question which you can observe in the networks or electrical circuits. The same question will be in the power system basics, and the same question will be in the measurement subject. Okay. So likewise, you can take any subject here. The basic concept is if the reading of the two wattmeters are equal and positive in wattmeter method, positive in two wattmeter method, so they are observed here. So here the option may be positive or the option may be negative. Okay, I will tell you both the cases here. So positive cases, positive means here see. So theta is nothing but tan inversion of, okay, tan inversion of root 3 into W2 minus W1 divided by basic formula I'm writing W2 plus W1. So where the W2 and W1 are the wattmeter readings of the 2 wattmeter method. Okay. Now the case is that 2 wattmeters are equal and positive. That means the W2 value will be equal to W1 positive, equal and positive. That means that both are equal and positive values. Then the load power factor. So what is the theta value in this case? So theta value is equal to, so tan inversion of root 3 into W2 minus W1 is 0 divided by 2W. Okay. So tan inversion of 0 means what about the theta value? So theta value will be equal to 0. So from that the power factor will be cos theta. So this value will be power factor. So power factor will be cos. Okay. So cos 0 means, sorry, it's my mistake here. Okay, right. So cos theta, so cos 0 here. So cos 0 will be 1 here. Okay, right. So cos 0 will be 1. Now, the same cases is a different here. So when you are talking about, it is when W2 will be equal to minus of W1. At the time what will happen is theta is nothing but tan inversion of, so root 3 into 2 W1 divided by, when the both are equal means 0. So at that time theta will be what is going to be infinity. Okay, so theta will be infinity. When the theta will be infinity, what about the power factor? So this value will be infinity. Theta will be equal to 90 degrees. Okay, so 90 degrees. So power factor will be 0 here. So power factor will be 0. So when the case is negative, answer is this one. When the case is positive, unity here. Okay, hope you are following the concept here. Now, next question. This is question from the power system here. Okay, as I discussed in a previous video, how to prepare for the JETCO examination. There you can see most of the questions are coming from the basic electrical engineering and the power system only. Okay, so please go through that video if you are not familiar with that video. Now let's see the question here. A three-phase supply floating neutral is undesirable. Floating neutral means, let's say here there are a three-phase system here like this. So this three-phase system is a having a floating neutral means, just for assumption I'm just making this switch here. Okay, so switch here. So this phase will have some voltage, this will have some voltage, this will have some voltage. Let's say R, Y, B. Now the voltage between these two is say V R Y. Between these two phases is V Y B. Now here when the system is a balanced here, the neutral current IN will be sum of IR plus IY plus IB. So this will be equal to 0 here. So this will be equal to 0. Now the floating neutral condition is undesirable. Because why it is? Because see here, for example, let's say the line to line voltage is a balanced one here. Because of this floating neutral, the phase voltage changes automatically. The line voltage is going to be changes here. As a difference between the these two quantities will changes, automatically unequal line voltage will happen. So here it is unequal line voltage. Sir, why it is sir? I will just give a simple example here how it is. See here, we are talking about the line voltages. So I will take for only one phase. I am not going to discuss entire here like this. And let me take some other phase here. So like this, we have three phases here. Okay. So I'll just give you an example here how it is. Now here we have like this. We have three phases here. At any particular point here, observe the difference here. If it's a balanced system, then the VR, okay, so plus Vy plus Vb is equal to 0 here. Okay, but because of this floating neutral, okay, what will happen is the voltage is going to be unbalanced here. So that's the reason why there will be unequal line voltages here. Next one, for which of the following materials is the Hall coefficient is 0? The Hall coefficient is 0, especially for the insulators. Okay, the Hall coefficient is positive for, so positive value for the mm, mm, holes, okay, negative for electrons here, okay. But again, the given option is intrinsic semiconductor, okay, but the actual answer will be insulator here. Next one, the conductivity of aluminum is a more time that of the copper. As we know that the aluminum is nothing but it's a conductor, okay, which is having a higher amount of resistivity compared to copper here. So that's the reason why, suppose if the R resistance aluminum is say given as, okay, so it is 10, okay, Ra is given as a aluminum, okay. So what about the Rb, that is a R cop, Rc is nothing but question here. Okay, the resistivity of aluminum is 0.6 times that of Rc. Now Rc value if you want means 10 divided by 0.6 is the answer here. That means the resistance of the aluminum is more, okay, or I can say the conductivity of aluminum is less. Understand the concept here. So resistance is inversely proportional to conductivity. Okay, so resistance is more means conductivity is less. Aluminum will have more resistance than that of copper, or I can say conductivity of aluminum is less than that of copper. So answer will be 0.6 here. The question may be asked like that. Okay, liquid crystal material is used in, so they are used in display devices. Whatever the cell phones we are using nowadays, they are super AMOLED or AMOLED displays. Okay, so in that AMOLED is nothing but liquid crystal material. So display devices and thermal sensors. Okay, the AMOLED devices, that is a light emitting diodes, but the similar concept of LCD. Okay, so LCD is nothing but liquid crystal display, right? The rating of the fuse wire is always expressed in. So this question is from the power system protection here. The rating of the fuse. So let's take a fuse here. The fuse symbolically represented like this here. Okay, what is the purpose of fuse is whenever the current carrying by the element, or let's say here, let's take a source here, and here I will take a load here. No, whenever current carried by this fuse, let's say here rated will be, so I will say I rated will be 5 amperes. If it's carrying IR, okay, it's nothing but 5.1 ampere. Means what the happen is, because of the property of this fuse, it is going to be melt down. So as a meltdown, it is going to be open. So what's the actual rating here? Its rating will be in currents, okay, which is always connected in series with the element to be protected. So answer will be amperes here. Okay, the sensitivity of a relay will be depends upon the volt amperes. Okay, the battery rating will be ampere hours. Next one. See here, the thickness of insulation provided on the conductor depends upon. Okay, so let's take the concept here. Let's take a conductor here like this. Okay, and the conductor, if we need any cable here, so on the top of it we have some insulation like this round. Okay, why it is going to do is because it is going to provide the insulation based on the voltage rating. That means here let's take a conductor here, simple conductor. Okay, so we are covering with it a cable here. We are covering with it a cable here for understanding purpose, cable here. Now what is the strength of this cable means, so let's this wire is carrying a voltage of 230 volts, and here the cable outside atmosphere will be 0 volts. So depends upon the atmosphere here. Okay, the insulation will be decided here. So what is the difference between these two? It is a 230, is it 230 volts? Sir, whatever, suppose if the insulation here, it's not a 0 volts outside here, so it will be say, so 115 volts. Then what is the thickness here? So 230, 115. Difference is what? It's a potential difference of 115 volts here. So at that voltage we will apply potential difference here. So remember here, the insulation depends upon the voltage rating. The current carrying capability depends upon the cross section area here. Okay. Next question here. Which of the following is not a true for sulfur hexafluoride? We'll call as a Sf6. Okay, Sf6 gas. So which is used in the power system protection, especially in a vacuum circuit breakers. Okay. Now here, the question here it is, which of the following is not true for the sulfur hexafluoride? Okay. So sulfur hexafluoride is going to be used as a arc quenching medium. So it is used to reduce, or we can say reduce or quenching arc between circuit breaker contacts. Okay, now suppose if you, instead of using the, let's say, chamber here, so here we have fixed coil and here we have moving contacts like this. Okay, so when you are going to open the circuit breaker here, instead of using, say here, if you are using a VC, so here if you are using SF6, okay, when the contacts are going separated, there will be an arc here. That arc is quenched by SF6. Suppose instead of using here, let's say petrol or kerosene or diesel, okay, if you're using that, what will happen? Because of that spark, it's going to be explosion will take place. It's going to be simply burn. Okay, so that's why SF6 is not a inflammable. Okay, so highly inflammable. It's not a inflammable gas. It is a electronegative in nature. It has a high electric strength. It is not a toxic. Why? Because when any operator is going to open the SF6 circuit breaker during the maintenance, suppose if it's a toxic means the person or operating person may get a health issues, right? And it have a good dielectric strength. Otherwise, the arc quenching will not possible. Okay, it has electronegative gas. That is the reason why it's going quick in response. So the correct option will be, it is highly inflammable. It's a wrong option. It is not a flammable. Okay. Next one. So a fuse is, so it's a very simple concept here. A fuse is never inserted in the neutral wire. Normally inserted in phase wire. Okay, normally inserted in neutral wire. Never inserted in phase wire. So generally a fuse is, say for example, if I take a three-phase system here, let me take a three-phase system for your understanding purpose. So you have entered a star connection system here. Now in order to protect the element, here we use the fuses in a series with the phase wire. Okay, so what about the neutral, sir? So here we have a neutral. What is the purpose of fusing here neutral? Okay, so you know the concept of arcing grounds. Okay, arcing grounds. What will happen is, if you are using a fusing element here in a series with this ground here, suppose in the previous case we have seen it's a 5 amperes current carrying capability. If you are using a 5.1, it's going to be open circuited. because of open circuited here, the healthy phases of this phase system is going to be becomes unbalanced system. That means the voltage will be higher. Okay, that's what we can call as a arcing grounds here. So to avoid this one, we will not use a fuse in series with a neutral wire here. Okay, your fuse is never inserted in neutral wire, but it may be inserted in phase wire. It may be inserted in, okay, so inserted in phase wire here. So the options are correct here. So these are the normally inserted in phase wire. Okay, normally inserted in neutral wire. So that's a wrong option here. Okay, normally inserted in phase wire. So never inserted in neutral wire here. Okay, so that is a correct answer for this question. So that's it for this video. We'll continue the next upcoming videos. Okay, thank you friends, have a nice day.